So last day we ended our discussion till this particular slide. We have seen that there are four different types of grammar we can have according to the classification by Noam Chomsky, and we also have seen that different type of production rule that actually uh, related. I mean, how the production rules, the form of the production rules are related for each and every grammar and their corresponding machine. So as we have decided last day that we will start from regular grammar. So we will go the grammar and the machine one by one. So let's start from the regular grammar. We also have seen in this particular architecture that how the different type of grammars are related. Now let's start regular grammar from today. By definition of a regular grammar, we have seen that a grammar G can be defined as if a grammar is regular and that by definition of the grammar, G is equal to V, T, P and S, the combination of these four entities, where V is set of non-terminals, T is set of terminals, P is set of production rules and S is the start symbol. And the type of the production rule in case of regular grammar is A to capital A followed by B. That means in the left hand side we will have a non-terminal, and in the right hand side we will either have a non-terminal followed by a terminal or a terminal followed by a non-terminal, either of these two. And also it's possible to have capital to small b. That means a non-terminal can be rewritten as only a single terminal. So now question is that why I am saying either A to capital A to capital A small b or capital A to small a capital B will be there. Why not combination of any combination of them? You will realize it very soon. So let's take an example of this regular grammar. Something like this. Suppose a grammar is something like this. Now you see, if you just check the corresponding production rule, if I assume this is the production rule number 1, S to SB, and S to A is the production rule number 2. Now using these two production rule in some particular order, you can generate some string, and all the set of strings that can be generated from this grammar will actually reflect the language that is generated from this grammar, right? So if I assume that, for example, this is rule number 1 and this is rule number 2, and this S is the start symbol, so using rule number 1 first time, I can write capital S as a combination of S and B as I have written over here. Now if I expand it more, I cannot expand in this direction because B is already a terminal. It is not possible to expand if I get a terminal, because expand is only possible if the symbol that we have over here should be in the left hand side of some production rule. But by the nature of the production rule of regular grammar, we have seen that it is not possible to have a terminal symbol in the LHS. That means as soon as you will get a terminal in some particular direction of the tree, it's not possible to expand it many more from that point. But you can expand this part because it is still now a variable, I mean a non-terminal, and I have two options over here. So if I expand it more with respect to the same production rule number 1, I can write something like this. Even again using rule number 1, the expand in this direction will be something like this. And then if I apply rule number 2, then this S will be rewritten as only small a. As that means I have used rule number 1 first, then again rule number 1 for this part, then again rule number 1, and then rule number 1, and then we have used rule number 2. So this is the order of using rule numbers for producing some string. Now how we find what is the string? Always remember, we start checking from this point and go downwards. You can say, in other words, the approach of finding the string is top down, top down, left to right. What does it mean? It means that we will start journey from this root of the tree, and from that means it is topmost one, and we will go downwards in this direction. Okay, so in this way I will go downwards till I am not able to find the leftmost leaf node. So leftmost leaf node of the tree is A. As soon as I will find the leftmost leaf node, so this A, now I will come in this side, then I will go upward. So you see that I am going down, I mean from top to downward, and I'm going in the left to right in this direction, something like this, So in this particular journey, if you consider the symbols A and B, B and B, the order of uh, visiting the symbols is something like first this A, then this B, then this B, and then this B. That is why the string is given as A triple B. Now whether it will be A triple B or A double B or only small a or A then n number of B's, it totally depend upon how many rule number 1 and then rule number 2 you are using. If I assume that you are using only rule number 2, that means you started from S and at the very beginning you rewritten S as small a. As soon as you have written this, there is no way to expand it. That means the string that is generated from this particular production rule or from this particular tree is actually only A. Don't mix up this A with this S with this S, because this S represents start symbol and this S is representing basically string S. If you have some confusion, you can rewrite this S as a W also. Okay, so this W we frequently used as a symbol to represent a string. Anyway, so now if I expand it more, I mean if I take one more example, something like this. Now see what is the difference between these two cases. Difference is in this production rule number 1. because in the rule number 1 of this left hand side we have the non-terminal first and then the terminal, but it is just exactly opposite in this case. So, and again I have rule number 2. So if I use this set of rule, I mean the rule numbers 1 and 2 of this second case in a exactly same order as we have done in this particular part in this slide, then what will happen? Obviously, AC start symbol again over here, and I will use rule number 1 first. So what will happen? Now see, in the L left hand side part is stopped. You cannot expand the LHS part. I mean, sorry, the left child part, rather you can say, or left subtree part. But right subtree part contains some uh, non-terminal. So you can expand it more, something like this. You can expand it again, something like this. So again, we are using this rule number 1 3 times, but because of this particular difference, the structure of the tree is changing, and that is the important part. And then if I use rule number 2, then again it will happen something like this. So if you start journeying to find out which particular string will be generated, it should be something like I will start journey from here and exactly in the same way top down, and as soon as I will get a leaf node I will go in this way down, something like this. So in this journey the order of visiting the symbols is this B first, then this B, then this B, this A. That's why the string, or you can say W, is generated B, 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 A. Now obviously how many B you can generate, you have to generate, depends on that. You have to use this rule number 1 that many times. So the number of times a particular rule that you will use, that totally depends upon the the grammar, the string that I want to generate. Now see, let's take some more example, something like this. You see, this is also a grammar of a regular, I mean a production rule of a regular grammar. But you see, this is what we call right linear grammar. Now why right linear grammar? The reason is that if you check the LHS side, we have S, and if you find the RHS side where S is present, S is present in the rightmost side of the production rule. Since S is in the rightmost side of the production rule, that means you can expand the tree towards right side only, and that is the reason why we call right linear grammar. So this is an example of right linear grammar, this one. So if we have a right linear grammar, then obviously we must have a left linear grammar also, something like this. So that means you see over here this side, it's entirely changing in the left direction, if you see. So this is an example of left linear grammar. So this is what actually is shown over here. Now see, this is an example of a left linear grammar. Why? The reason is that if you see the number of production rules, there are how many production rules is present? S2, S1, AB. This is production rule number 1. S1 to S1 AB. This is rule number 2. S1 to S2, this is rule number 3, and S2 to A. By the way, I had a mistake. S1 to S2 is not possible. The reason is that it doesn't support, S1 to S2 is not a valid production rule of a regular grammar, because in the type of the characteristic of the production rule of a regular grammar say that right side should have either only a single terminal or a non-terminal followed by terminal, or terminal followed by non-terminal, but not a single non-terminal. So if a single non-terminal is not accepted, that means this production rule is not correct. So I had a mistake. So just for time being, if we say that just forget about this particular part, and instead of 2 if you consider 1, okay, so S1 to A, it is possible, S1 to A is possible, S1 to this one is possible. And you see in these two part, where whatever production rule that we have, the non-terminal that we have in the LHS is present in the left most symbol in the right RHS of the production rule. That's why it is called left linear grammar. That's why left linear grammar. Now, every time it is not possible, that may not be possible, right? I mean, a grammar can be something like this also. Again, I have a problem, I'm sorry. I should have something like this. Okay. Okay. So, what is this? This is another grammar. This is another grammar. Where with respect to this production rule, the grammar should be left linear. But with respect to this production rule, at least if you forget about B right now, you think A to a small a capital B, then it is right linear grammar. Because the non-terminal present in the right side. Again, with respect to this production rule, it is left linear. So, unlike the previous cases, here we have seen that the grammar consists of n number of production rule, and each and every production rule is not following same pattern of uh, production rule. Some production rule is following a pattern of right linear grammar, some production rule is following pattern of left linear grammar. So that's why this is not a regular grammar. But what we can say? This is a linear grammar, but not regular. I mean, I can say this is neither right linear not left linear. Since it is neither right linear or not left linear, that is why we can say the grammar is not regular grammar. In that case, you have to note this very important point, that in a regular grammar, at most one variable appears on the right side of any production. Furthermore, the variable must consistently be either rightmost or leftmost symbol of the right side of any production rule. If it is a combination, then the whole grammar as a whole is no more remain a regular grammar. But what we can say? The grammar is a linear grammar. But you don't misjudge that this is not a regular grammar. This is also a regular grammar. This one is also regular grammar. This is also regular grammar. I'm sorry, I had a mistake. It's obviously regular, we have seen that. This is linear grammar. And regular grammar. This is linear grammar and regular grammar. This is linear grammar but not regular grammar. So that means what I have seen from this example, that all regular grammar are linear. If a grammar is regular grammar, that means surely it is a linear grammar. But if I say that I have a grammar which is linear grammar, it doesn't guarantee that grammar will be regular. To be a grammar as a regular, to be the linear grammar as a regular, the production rules of the grammar should follow either this either rightmost or leftmost symbol should be in the right side of the production rule. That is important. So this type of sometimes question comes from this point. Grammar is given and it will be asked that whether it is regular grammar or maybe linear grammar. That means when if a grammar is given to you and if someone asks you that whether it is regular grammar or not, don't check only individually whether the production rules following following what I can say, whether the production rules are following something like A to AB or A to BA or A to C, these production rules. Don't check in this way. Also you have to check whether there is a mixture of A to capital A small b or capital A to small b capital A. If there is a mixture, then it is not regular. Okay. So